All right, I also want to show you what it looks like in HAWX when you go to do these problems. So let's open up practice, and I'm going to find a transformation problem. Okay, so there's actually a couple different types that they have, but they're all doing like transformations. There's just some of them ask, you know, this other thing, and some of them ask a different other thing. Okay, so determine the more basic function that has been shifted, reflected, stretched, or compressed. So this has absolute value in it. So the most basic function, oh, it doesn't let me type pipe. Okay, cool. The most basic function then would be our absolute value of x. Okay. Then you're asked to identify the shape. So the absolute value has the v. That's always something that I wrote down when we were doing these transformations. So there's the v shape. And here's the thing where we actually list the transformations. Your shift, stretch, reflection, reflection, and vertical shift again. So this thing does add and subtracts. So they have this written as -1 plus 2 times x, absolute value of x plus 2. Another way you could think of writing this, actually let me so instead, think of writing it as 2 times x plus 2 absolute value minus 1. Okay, you can actually think of this as 2 absolute value x plus 2 minus 1, right? So a lot of times when students see this, they're confused because this isn't in the form I've been doing it in the examples. But this is still a subtraction of 1. Okay, so do I add or subtract? Yes. I have this minus 1. That's on the outside. I can go ahead and scroll down real quick. That's a vertical shift down by 1. Okay. Let's see what else. Oh, I also add 2 on the inside of my absolute value. So that's a horizontal. Horizontal is always the opposite. So since I'm adding, I'm going to move to the left, because your intuition would be add, move to the right, but it's actually the opposite. So 2. Stretch and compress. So their distinction that they make about stretch versus compress is if it's a fraction between 0 and 1, it's a compression. If it's larger than 1, then it's a stretch. So here I multiply by the number 2. So I'm going to stretch it by 2. Reflection. So for reflections, I'm looking for multiplication by negatives. I don't have that in either one of them, so no reflections at all. Now, if you do a table, so this does all the transformations for you as you fill them out. It just makes the picture. If you do the table method, which I think is, at least for checking your HAWX work, I think that that's the easiest. If you do the table method, you can make sure that the points that you get on the table match the points that are on your HAWX graph. So what I mean by that is, if I'm doing 2 absolute x plus 2 minus 1, so I start with my x, I do my horizontal shift to the left by 2, I do a vertical, oh, that has to be last, yeah, vertical stretch by 2, and then I do vertical shift down 1. Now I'm going to do this rather quickly just so we can see the points. So -1, 1, 0, 0, 1, 1. Move left 2, which means my x value decreases, my y value stays the same. Oops. Vertical stretch by 2, x stays the same, y multiplies by 2. Shift down 1, x stays the same, y subtract 1. Okay, so if you do the table technique, what you should end up with are these 3 points. -3, 1, -2, -1, -1, 1. Okay? So if I check my Hawks, so -2, -1, that's there. -1, 1, -3, 1. Okay, so this matches what I've done with my graph. So your work that you turn in now supports your Hawks answer. And I submit that. Hooray. Well done. Okay, now the thing that they ask you on a lot of them is the domain and range. Now, you have a picture, and actually I think you can see, yeah, you can click previous step answer. Domain is the X's, range is the Y's. So as I travel left to right, which X values are taken in? Or, back in 4.1 we did implied domain, are there any square roots, and are there any denominators that could be 0? No, for either of those. So the domain of the absolute value is all reals, which I think I need to use the keypad for. I do. Okay, there it is. The range is the Y's. So as I travel from -infinity up to infinity, my function's not on, not on, not on. Ah, it starts here at -1, and then it goes up to infinity. So my range would be -1 to infinity. All right. Now before I move on from that, I want to point something out. Whatever transformations you've done to the function are also done to the domain and range, right? So usually your absolute value looks like this. Usually, so absolute X, usually has a domain of R and a range of R. Sorry, blah, 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 not true. A range of 0 to infinity, usually. So with the absolute value, you can always plug in anything, and it always outputs something non-negative. That's what this says. So in my transformations, I shifted left by 2. I shifted my X's. That's my domain. I shifted that left by 2. Now if I pick up the whole real line and shift it left by 2, I still have the whole real line. So this domain didn't care that I shifted everything left by 2. It's still the whole domain. Okay, so this one didn't change. That's why my domain is still, that's one reason you can think of why it's still all of R. Vertical stretch by 2. All right, so this is stuff that's changing Y values now. So stretch by 2. If I go from 0 to infinity, I multiply 2 by 0, I still get 0. But if I multiply infinity by 2, whatever that means to do, I'm still going to go up to infinity. So this transformation does not affect my range. Okay. Vertical shift down 1. So now I'm going to subtract 1 from each of these. Well, infinity is infinity. You can't really subtract 1 from it. It's still infinite. It's like picking up my real line from 0 to infinity and scooting everything down 1. So it still goes up to infinity, but it just starts a little bit lower. So you go -1 to infinity. So you can either do domain and range from the graph, which is, I think, what they want you to do in Hawks. That's kind of how they've set it up. But you can also think about it in terms of doing the transformations on the original domain and range. That's the whole point of the transformations. So horizontal stuff changes your X or your domain. Vertical stuff changes your Y's or your range. Now, the 4 functions actually were x squared, x cubed, root x, and absolute x. So this is super sloppy. This is just like extra stuff I thought of while we were doing a problem. Okay, so here's our crappy pictures. What goes into a x squared? Anything. What comes out? Non-negatives. What goes into an x cubed? Anything. What comes out? Also anything. So for x cubed, no matter what transformations you do, the domain and range is always R. Always. Because you start with the whole real, so no matter what you do to the whole real line, you still end up with the whole real line. Square root of x, the domain is 0 to infinity, and the range is also 0 to infinity. So this one, both x and y transformations are going to affect your domain range answers. And then absolute x is just like the x squared, all right? So x cubed never cares. X squared and absolute x only care if you do something with changing the y values, and square root of x is the one that cares if you do either one of them.